Alright, we're live. Alright, so correlations. First thing we talk about today. It's in your note packet, starts out day 4. Correlations. We're dealing with in which way, I guess, do the plotted points go. Right? A correlation is telling us which way the plotted points go. If I'm plotting a bunch of points and it's said to have a negative correlation, that means if I look at it from left to right, the points should be going in a downwards motion. It almost looks like if I drew a line, it would have a negative slope. Right? A negative correlation is just the plot of points going downward. No correlation is if I just plot a bunch of points in random spots. There's no rhyme or reason for which way they're being plotted. There's no direction to them being plotted. They're just all over the place. That means there's no correlation. And lastly, a positive correlation, if I look at it from left to right, the points that I'm plotting are going at an upward slope, almost like a positive slope. So that'd be a positive correlation. Right? We may ask you, like on the homework today, there's a couple problems that says, what type of correlation is it? Positive, negative, no correlation. That's what the extent we're going to go with this. Alright? Pretty self-explanatory, pretty common sense, right? Alright, then I'm going to keep going. The next thing we're going to do, we're going to skip that problem on top. Skip the problem on top. We're just going to go right to filling out how we approximate a line of best fit. Now, line of best fit is going to be something that we draw in. We're given a data point. We're giving a scatter plot. We are drawing in a line of best fit or a linear equation to fit that data. It is an approximation. It's an estimation. Yours may be different than mine. That's perfectly okay. But what you're going to do is you're going to show me your work. So if, like on a test, I tell you to do a line of best fit, I can follow your work. And I can see why yours is a little bit different than mine. Alright? It's okay for that to happen. Here's the steps for making a line of best fit. We're going to draw a scatter plot of the data right off the bat. We're going to get like a table of data or some list of data, and we're going to make a scatter plot with it. Step 2, we're going to sketch our line of best fit. We're going to sketch that line so it appears to follow most closely the trend given by the data points. So we're going to try and follow along with the data points on our line. It's going to be a straight line, a linear line. There should be about as many points above our line as below it. Now, if there isn't, that's okay. If you have like 4 above it and 3 below it, that's perfectly fine. And we're trying to find the best line of fit for each different data set. Just because we don't have as many above as below it doesn't mean it's not the best line. Right? Step 3, we're going to choose 2 points on our line and estimate the coordinates of each point. This should be pretty easy because when you draw your line, you're going to try and make sure that you go through 2 points, whether it's 2 points that you plotted, or 2 nice points on the graph, or a point that you plotted, and a point on the graph that's nice. And we're going to estimate the coordinates of those points. Because we're going to take those 2 coordinates, and we're going to write an equation of our line that passes through those 2 points. So we're going to make an equation for our line of best fit. That's our 4 steps. Not too hard, a little tedious at times, but it's really not that bad. Okay? Any questions? Alright, let's roll. First problem. The table below gives the number of people Y who attended each of the first 7 football games X of the season. Approximate the best fitting line for the data. So we're given a bunch of data about how many people attend each football game. We have a graph over here. It's already labeled for us. It's already set up. All we do is step 1. What was step 1?
Draw a scatter plot.
Draw a scatter plot. So what I'm going to do is I'm going to take my values from over here. And I'm going to plot them on my graph. 1, 722. 2, 763. 3, 772. 4, 826. 5, 815. 6, 857. And 7, 897. Like, guys, we're estimating these points on the graph, right? So it's your best estimation. Then once you've plotted them, we're going to go to step 2. We're going to draw a line of best fit on here. You're going to use a straight edge. I wouldn't start drawing until I'm comfortable with the line that I've given myself. Right? So my line, I'm going to look at it. I'm going to go through right about there. I want to look at that line, make sure I like my line, make sure I go through 2 nice points at least, make sure I have about the same amount of points on top as I have below the line, about 1, 2 above, 1, 2 below, and I go through about 3 points, right? I'm trying to find the line that best fits the data I just plotted. Like I said, yours may be different than mine. That's perfectly okay. Just show your work. It shouldn't be too far off, but it's okay to be different. That was step 2, draw my line. What's step 3? Choose 2 points. So, it just so happened mine goes to the first and the last point. So I'm going to use those 2. You don't have to use those 2. I'm going to use those 2. My points then are 1, 7, 22, and 7, 8, 97. Okay? Now, step 4 tells me I need to write an equation using those 2 points. Well, when I write an equation, what's the number one thing I need? Slope. Right? I need slope. I don't have slope right now. I have 2 points. Can I find slope from 2 points?
Yes.
Yes, how so?
y2 minus y1 and x2 minus x1.
y2 minus y1 over x2 minus x1, right? It's our slope formula. Change in y over change in x. So plug in our points. 897 minus 722 over 7 minus 1. Should get 175 over 6, which comes out to approximately Sardina, put in your calculator. Tell me what you get. 175 over 6.
Approximately 29.
Approximately 29. Is there a decimal there?
Yes.
Let's go to the first decimal.
0.2.
0.2. Sweet, thank you. So approximately 29.2. So now I have a slope. And I have a point. How do I find my equation? I have a point and I have slope. Point slope form. Y minus y1 equals m times x minus x1. Y minus y1 equals m times x minus x1. Alright, so y minus 722 equals 29.2 times x minus 1. And solve it to get it to slope-intercept form. Right, get it to say y equals so we can find it in slope-intercept. Distribute your 29.2. Y minus 722 equals 29.2x minus 29.2. Add 722 to both sides. We should get y equals 29.2x plus 692.8. Right? Do I get that? Do we have any questions how I got that? Do we all follow me? So line of best fit, doing it by hand. Right? Now it's asking me to use this line to approximate how many people attend the 8th game. Does anyone have any idea how we can do that? Xander, what do you think?
Substitute x for 8.
We'll substitute 8 for x, right?
Yeah.
So take 8, plug it in for x, because we said our x value, our x variable, is the number of games, or the nth game, whatever game it is. So y equals 29.2 times 8 plus 692.8. So if I plug in 8, I'm going to get y is approximately how many people? Did you do it?
No, I have different points.
You have different points? Yeah. Okay, sweet. So when I say my answer, I want to know what yours was then. See how close we were. Okay?
926.4.
926.4 people. Okay? 926.4 people. If you want to round it to 926 or 927, that's perfectly fine. Because if you bring 0.4 of a person into a game, you'll probably get arrested. So, what'd you get?
I had 897 because I used the first and the third.
The first and third point?
Yeah.
So your slope and your intercept are probably a little bit different, right?
Yeah.
That's fine. As long as you show your work, you should be okay. Alright. Number 3. Okay, so 1 and 2 we're doing line of best fit. That's by hand. Whenever I say find the line of best fit or the best fitting line, that's doing it by hand on your graph. 3 is going to be asking for a linear regression. Linear regression is going to be the calculator's line of best fit. So now you're going to break your calculator out, and we're going to do it on our calculator. First thing you need to do, what are y equals on your calculator? Y equals, top left. If you have anything in your calculator that enter the y equals, you need to clear it, get rid of it. So hit clear. So make sure your y equals is cleared. Okay? Also, make sure your plot 1 is highlighted. Later on we're going to need it. We won't need it for this problem, but while we're here, we might as well turn it on. So plot 1, make sure it's highlighted. If it's not, go up to it, hit enter, and it should be highlighted then. Okay? Now, like I said before, I am going to go a little bit quick through this. There is a PDF form on Schoology that'll walk you through step by step what we're going to do right here. Alright? Also, I'm going to put this video on Schoology so you can go back and watch it if you need. Alright, our second step is go to stat edit. So what you can do, stat is right below delete. Edit's the first one that pops up, just hit enter. We are looking for L1 and L2. Alright? In L1, we're going to take that table that we had before, using the same data set. We're going to put our x values. So in L1, I want you to put your x values. 1, 2, 3, 4, 5, 6, and 7. So L1 is going to be my x values for my problem. L2 is going to be my y values for my problem. So 722, 763, 772, 826, 815, 857, and 897. Do not rearrange them, they need to stay together. Right? So let me know when we get to this point, once we have this in. Okay? How we doing? Okay, so I put x and y in. My next step. Now look here. Turn on stat plot. We did that already. Now, what we're going to do is we're actually going to check. I'm going to do this right now with you guys instead of doing it later. And I'll talk about it again in a second. What you need to do from here is go to zoom. And then you want zoom stat. So zoom 9. And it's going to plot your points for you. It should. Now, the reason we do this is if I look at a graph. This problem is a linear regression problem, right? So it should look like it almost makes a straight line. Right? Just like that. Okay? Should almost make a straight line. Now, in a second we're going to do an exponential regression problem. Does anyone remember what an exponential graph looks like? Anyone? Bueller. It's almost like a half U, right? It starts down here and it grows really fast at some point. We're going to do exponential regression in a second, but what you need to do is you need to double check that it is linear. Now in this case we look at it, we see it's linear, we're good to go. So, I'm here, I checked it, I graphed the points. I'm going to go to stat, calculate. So go back to stat. Go over to calculate. We said it's a linear regression. Right? We said it was a linear points. We saw that. We just graphed and we checked it. Now there's two different linear regressions. AX plus B and A plus BX. Which one do you think we're going to use? AX plus B, right? It's just like Y equals MX plus B. Right? It's going to give me a slope and it's going to give me an intercept with what I'm already dealing with. So I'm going to go down to 4, or I'm just going to hit 4, and then hit enter. The older calculators, it won't pop up like this. Like yours will just say linear regression L1, L2. That's perfectly fine. You want to say L1, L2 because that's what you have X and Y in. Right? The new one that's going to ask you your X list. Well, we put it in L1. our Y list, we put it in L2. If it ever changes for some reason, all you would do is hit second, and you look 1, 2, 3, 4, 5, 6 of L1 through 6 above them. So now I just hit 1, so I want L1, and it would pop in there. And then I'm going to go down to hit calculate. For you guys, I can just hit enter once you've got it on your screen. It didn't work? What? Okay.
The second L1.
Let me do this right and then
Okay, so you don't need to put L1, L2.
Oh, okay.
Alright, so guys, A equals 27. A equals 27. B equals 699.42 dot 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 dot. Right? That's what it tells us. But we want an equation for our linear regression. Do you have a question?
yeah, I calculated.
I'll be there 1 second. Okay? Hey, shh. Guys, how do I put this into an equation? Look, y equals ax plus b. Plug in A, plug in B. Y equals 27x plus 699.4, we'll say. That's my equation. So what I want you to do then is answer number 4. It's the same thing we did number 2, but now we're using our wow, words are tough. Linear regression formula. Holy wow. Good thing I'm not an English teacher. All right. You put add, yeah. You put yours in. And if we do stat, well, okay, so we do zoom 9. Well, here we do put our stat one. Enter. That's so zoom 9. At the bottom. And stat. Calculate. Enter.
Using that equation,
L1, L2. Calculate.
so instead of x, you know, it's like 27x, you know, 27a, it's like times.
Could you make your x equal?
Okay, so you hit stat. Over to calculate.
It keeps shutting off.
Linear regression.
I haven't had to charge. I just read for you. Do you want to see?
No, I have the same one as yours, but
I've never charged.
Alright.
I don't charge it.
Blowers.
Yeah, another one.
What'd you get for number 4?
Never even.
Since I know you did it, because I asked you to do it.
I don't know.
What'd you get? How many people?
915.4.
915.4. Alright, so, guys, listen. Let me stop talking. Thank you. So, you'll notice mine was 926.4. The calculators was 915.4. Israel is right about 897 point something. Right? So it can be different. The calculator is obviously probably the most accurate, but our lines of best fit should hopefully be somewhere close to them. Okay? Any questions? Alright, then, next thing. I think we skipped the next one if I'm correct. Yeah. So we're not going to do the next problem. And what we're going to do is we're going to go to the sheet that you picked up when you walked in. Alright? So, that sheet, we talked about how do we decide if it's linear or exponential. We kind of talked about this already, right? I skipped ahead a little bit. So, we can tell if it's linear or exponential by the way the points are shaped. Right? If it makes kind of a half U or a J. If it makes a half U or a J, it looks like this. That means it's going to be, excuse me, it's going to be an exponential regression. Right? If it's a straight line, or it would appear to be a straight line if I drew one in, it's going to be a linear regression. That's the way we can choose between the two of them. We need to make sure we're using the correct one. Because in the calculator, there's a different function for exponential regression than there is for linear regression. Alright, so we need to figure out if it's linear or if it's exponential. Okay? Alright, flip your paper over. We're going to graph an exponential regression. Wow, the spelling is terrible too. On the graphing calculator. So a new highly dangerous bacteria has been discovered. It has been determined that if a human is infected with a population of 1 billion of these bacteria, he or she will die from the infection. So researchers know that a person will likely come into contact with 500 of the bacteria at the initial point of infection. So we are going to be asked to figure out how long do we have to save this person or how long does this person have to live. So, first thing we're going to do is we're going to plot the data points. So we're going to take our values and we're going to plug them into our first two lists. Right? My hours infected is my X, or it's going to go into my list 1. My number of bacteria is my Y, or it's going to go into list 2. So, take out your calculator. Stat, edit, list 1, 0, 1, 3, 5, 7, 9, 9, then 15. List 2, 500, 597, 817, 1153, 1620, 2240, 6160. So I'm putting all my points in there, and then I'm going to check to see, is this going to be an exponential regression or a linear regression? So I'm going to hit zoom, 9. The points pop up, I look at them. Is this an exponential or a linear? Exponential. So now I know I'm going to have to do an exponential regression in my calculator. Alright, so I look. I know it's exponential. So I'm going to find a function that approximates that. So, I have all my points put in. I'm going to hit stat. Go over to calculate. But I can't use number 4. I cannot use a linear regression. I just said it was exponential. You'll notice if you go down far enough. Go down to the 0. It says EXPREG. That means exponential regression. So instead of clicking linear regression, I'm going to click exponential regression. My X list is still L1. Y list is still L2. And I can go down and hit calculate. It's going to tell me my equation is y equals a times b to the x power. It tells me that every time I do a regression. My a value is going to be 500.1455924, so on and so forth. My b value, 1.181997636. So if I go back and I write down that a equals 500.1 and b equals 1.18, and I write my equation y equals 500.1 times 1.18 to the x power, am I going to get an exact number that I'm looking for? Why not, Ty? Why do you say no? What happened with those numbers from the calculator to here? What did I do?
Round them.
I rounded. So I'm not going to get the exact same answer as if I round as if I don't. So that's the risk we have to take with that. Now, there is a way when we do our exponential regression that it will store it right into our calculator without rounding it for us. Alright, so I'm going to show it to you quickly. It would be stat, calculate. We go down to exponential regression again. It's the same way. So exponential regression, it pops up. Store regression equation. We want it to store into one of our y's. Now yours pops up, it just says exponential regression probably, right? You're going to do the same thing that we're doing, except you're just going to do it on your screen. Okay? Alright, so, store regression equation, you're going to hit vars. Vars is right to the left of clear. Go over to y vars. It is a function. So I'm going to click enter on 1. And then y1 is the one I want, just because it's the first one. I don't have anything in there. We cleared those out. It's going to pop up on my screen, and then I can hit calculate. Or then you guys can hit enter. It's going to pop up. It's still going to tell me that a equals 500.1. Still going to tell me that b equals 1.18. But now when I go to y equals, it should also be stored under my y1. So now I don't have to worry about rounding when I put it into my calculator. Alright? Like I said, I know I'm throwing a lot at you. That's why I'm putting the video online. That's why we have that PDF form online. But now it's stored in there, it doesn't have to round at all. Okay? Because it doesn't actually ask me on here. It doesn't ask me for an equation. It asks me to trace the line or use a table to determine how long it will take until we have 1 billion bacteria. Well, you're not going to see 1 billion on the table. You're going to see it as like 1 times 10 to the 9th or 1 e to the 9th. Now, if you're going to trace it, you're going to have to make sure that your window is really big. I would suggest using the table. So what I would do, calculator, second, table. And it'll pop up your table of x values, y values. You got to click down, find around, use the table start button to find where does it say 1.0 e to the 9th. Now, I'm going to do it up here for you because I already got it on my screen. We don't have to take the time to do it. Then you don't have to worry about it. So if we look at 86, which means 86 hours, I'm at 8.79 e to the 8th bacteria. At 87, I jump that gap. I get to 1.04 e to the 9th. So I know somewhere between 86 and 87 hours is when this person is going to die. Or that's how long I have to say them. So if you want to approximate approximately 87 hours, since that's the first one where it pops up, that's perfectly fine. Approximately 87 hours. So, that's the difference between linear regression, exponential regression. Remember, line of best fit is by our hand. We're doing it by hand. It's our approximation. Linear regression, calculator's line of best fit, and then exponential regression is just with an exponential equation. Okay? I think we added 2 other problems, but we're not even going to do them. I'm not worried about it. Alright, so Maddie, I need your help though. Can you hand out one of these forms to me, please?
Yeah. Because I listened to this one. I listened too. This is crazy. Are we crossing stuff?
I hope so.
I know, I don't want to do it.
I have so much homework already.
Yeah.
Guys, don't put them away yet. Don't put them away yet. I caught it. Alright, take out the gray homework. Gray homework, homework number 4. Cross out number 4. On the front, number 4 on the front. Numbers 1, 2, and 3 should take you about 10 seconds to do. Number 4 you can cross out on the front. On the back. Number 6 you can cross off. On the purple homework, homework number 5. Front side you can cross off 1 and 4. 1 and 4. And then on the back side, you can cross off number 7. The rest of it's homework for whenever we get back to school.